I want to officially welcome you to today's practical section, as well as answering 13 questions. My advice is that whilst I'm posing the question, write them down in pen and paper so that you can look at them at your later time. You should have your R Excel open for the Brukutu data set. You already know about this data set where quantity demanded is a function of price, complement price, average income of the people, the location of the shop, the occupation, as well as the religion of the people. You can see that the data set has categorical names, not just coded as it was in the app. I am using the Excel sheet, which is at the bottom called Brukutu R. That Excel sheet is what I'm using, the one known as Brukutu R. So when you open your Excel and you rather have the Brukutu Excel open, this one, if you rather have this one open, no, you got to go to the Brukutu R. That's the one you should have. All right, so that's the Excel. The other thing you should open is your R Studio. You click on the Start button, you start typing RST, that is the R Studio. You see the icon of the R Studio shown. You click on it, and you would have had the interface like this. But if you have not written anything there, everything on the console, on the command center, will be 0. Now the command center is this section here. That's a command center. Then the one at the bottom here is a console. Okay. The one at the bottom is a console. So this section here is a console. And then the main thing here are the packages. And then usually some data are shown here. But where we are going to be working a lot today are the command as well as the console. The command is where you type or where you put your writings. The console shows you the result. And occasionally you go and check your graphs on the packages. So the first thing we want to do is to take the data from the R to the Excel. The other way around, the Excel to the R. So to do that, you go to the Excel. This is the Excel data. You click anywhere inside the data, do Control A to highlight, Control C to copy. Do that and do that fast along with me. Okay. And then you come to your Brukutu, the R Studio. By then, you have already copied the command which starts with a gin. The gin equal to read.delim. This is a command you use to load the data from Excel. Now, when you click anywhere in that command, and then you run at the top, you either choose Control Enter or you click Run while the cursor is blinking on the section under here. Once you click Run, you will see that the name of the data will show blue. Okay, so I'm about to click Run or do Control Enter, and then look down in the console. The name of every command is showing blue down there, which shows that the data has been loaded. The data has been loaded. Now, if you are not so sure whether your data has been loaded, you can look at it by highlighting the gin. The gin is just a name I gave to the data because it's about gin bitters. If you are dealing with cars or water or salary, you can use a short letter. You can even use a single letter to represent the name of the data. So to show it, just highlight the name, the one on the left-hand side of the equal to, and click Run again. You will see, as you can see here, down in the console, you will see that all the data set is now showing down. You're done. You're done. That is the main part of the data. When you go to your Excel, you can run some descriptive statistics. Okay? You can run some, but remember, there are other things you can do with your data. You can generate something we call contingency table, and I want to do that. Before you generate the contingency table, what you will do is you have to run a package. So if you already have installed a package, you run the package. In this case, I'm running mass and ggplot. Mass and ggplot. I just ran it because I've installed them already. If you have not installed them, then one by one, you click on packages on this section here. You click on packages and choose install, and then come and type the name. So if the name is mass, as you start typing, it will pop. Okay. If it is capital, you have to make it capital. Okay. And then anything else. I have mine there. So it's already in there. Sometimes it even comes with the one you have selected. So you just install that one time and then run it by highlighting or clicking on it. And once it shows down there in the console as blue, it means you are done. Now, this will help you to generate a contingency table. A contingency table is just looking at the categorical variables you specify. So if you look at what I have here, I've written that inside the gene, I want you to juxtapose the religion, which is REL, the occupation, which is OCC. Please remember, whenever you see OCC and they have added U, remove the U and continue with the OCC. And then the location. All of these are categorical variables. So you're generating a table. I just did that. Now, let me maximize it for you to see. So in this table, you can see that we are showing the rural versus the urban. Okay? And for rural versus the urban, we are cross-checking the occupational levels, which is the top part, with the religious level. So as an example, to make sense of this, what are we saying? If I were to ask you that in the rural area, how many teachers were Muslims? What would you say? In the rural area, how many teachers were Muslims? What would you say?
4.
It's 4. And how many Muslims were in the rural area? How many Muslims were in the rural area?
12.
12. So based on the contingency table, you're able to get some feel of your data. Okay, you're able to get some feel of the data. How many teachers were in the urban center? How many teachers were in the urban center?
8.
Good. So that is how powerful contingency table is. Okay. You can generate a histogram. Okay. I have the command here. You can check it later in yours. Okay. You can generate a histogram by using this command. Okay. And this will give you a histogram of the quantity demanded. It gives you rainbow color. You can choose a rainbow color so that it gives you all the colors. That's what you have on the right-hand side. You can generate a box plot of the data. In this case, the quantity demanded. You can even generate a box plot according to location. Remember, location is LOC. So I'm just generating a box plot of the quantity demanded, but across location. And this is what you get. You can see that it gives me one for the rural location, and then it gives you one for the urban location. The middle part here tells you a lot about which one is having a bigger mean. Okay, it's having a bigger mean or a median. And you can see that the urban sector, the quantity demanded in the urban sector appears to be more than that of the rural center. So that is it. Now you can also plot the density. Okay? This command will help you to plot the density. You can try all of this on your own, and you can see that it shows clearly that the quantity demanded is not normally distributed. To check whether it's not normally distributed, you can do something called the Shapiro test. is also here. Okay? And when you run the Shapiro test, okay, when the p-value is more than 5%, it means that it's normally distributed. When the p-value is less than 5%, it means that it's not normally distributed. And in our case, look down here in the console, the p-value is less than 5%, and so it is not normally distributed. And it's obvious from the kernel density plot with 2 modes. Okay? We call it bimodal, a clear indication that the gene test is not normally distributed. There are other beautiful graphs you can draw for this. Okay? For example, when you install a package called Tiger Start, you can generate some other beautiful plots. You can color some of them. Look, there are several beautiful plots that you can generate. Okay? As you can see, okay? You can generate graphs. You can generate according to religion. You can generate according to. So your data set will have a lot of things, and you can test. You can test. This is called violin plot. You can test whether there are differences according to location, whether the quantity demanded differ across location. You can test. Okay? So that's a 2-sample test. And you can check the p-value. The p-value here shows that you have 6 zeros before the 1902. So it means that the p-value is approximately 0, which is a clear indication that there's a significant relationship, in the quantity demanded across location. You can do it across location. You can do it across other things. All of them will give you some result. Okay, these are just gimmicks and preliminary for you to just familiarize yourself with. You can actually generate several plots as well. Okay? You can check all of these things on your own. Now, you guys remember that, and again, when you go to the slides, you can generate other things like descriptive statistics. Okay? There's a command that you use to generate descriptive statistics. And as you can see, this command, before you do it, you have to run the psych package. So I can run the psych package here. Okay? And then after running the psych package, you type describe gene, the name of the data. Once you do describe gene with the name of the data, it will give you a complete descriptive statistics of all the data. Remember, we did this thing in Excel. Okay? Now, R gives you even more. Okay? You can see that R is giving you the standard deviation, the median, the trim median, the maximum absolute deviation, the minimum, the maximum, the range, the skewness, the ketosis, the standard error, and several things. You should be able to understand what each one of them implies. And when you get to the last 3, you can see that the variables have been starred. Why have they been starred? Does anybody have an idea why the variables have been starred? Any idea? Because they are categorical variables, because they are dummy variables. Okay. I've asked questions on this, that's why I'm giving it. Okay. Because they are dummy variables, that's why they are starred. So anytime R is very sensible, R is able to recognize that we don't need descriptive statistics for dummy variables, and it stars them to tell you or to give you a cautionary note. You can check whether any particular variable is normally distributed. Okay. You can use the quantile normal probability plots here. When you run that alone, you can check whether the quantity demanded is normally distributed. I can do that here. Okay. And that's it. The fact that it is not falling on the line, the blue dots are not falling on the line, means that it's not normally distributed. So you can check for the normality, any variable. Okay. You can check the normality of any variable. I've done all of this here. Everything I'm doing is in the slides too, so you can check it. Now we go to the correlation. Correlation. We did it in Excel. Now let's do it here. Okay. Let's do a bit of correlation. What is a correlation? A correlation looks at the relationship between two variables. Okay. So we want to run the correlation of the data set, but remember I am using the R data set, the R data set. So I'm going to run a correlation with this. If you run the correlation, take note, the dummy variables will not work if you use this command. So if you want the dummy variables to work, if you want to run a correlation, you got to remove the dummy variables. You can run a correlation like this. This command removes the dummy variables. So you can see that the variables are just the quantity, the price, the complement price, and income. You can see it at the bottom here. But you can also run it in terms of graph. So you can do scatter plot matrix. This command does that. Okay, command 202. Okay. It will generate, you have it in the slides, it will generate a scatter plot matrix of the numerical variables. You should be able to learn how to generate all of this. That's why I'm giving you an example here. And now, based on this, you can see that there's a positive or negative relationship. For example, between price and quantity, you can see that there's a positive relationship. It's the same thing up and down. Between quantity and complement, you see quantity and complement, okay, between this and that. You can see clearly that the relationship is showing a positive relationship. Okay. So you're able to use the scatter plot matrix to quickly determine whether a relationship is negative, positive, or neutral. You're able to tell that. For most of the dummy variables, they will usually be neutral. Okay. Now, you can also run the correlation with just 2 decimals. This command does that. It's 2 decimals. And you can see that the same thing as the correlation matrix above, but this one is just being 2 decimals in there. Okay. So there are several things you can do regarding the correlation. Just familiarize yourself with some of them. Like in the PDF, I have quite a few there. See, I have quite a few there. For the numerical variables, remember, for the R, you have to remove the dummy variables, the categorical variables, before you even run your correlation. You have to do that. Okay. Now, let's look at some questions you can have. For example, categorical and numerical variables. Okay, you can generate all of these correlations. Please note that the command here uses U, okay, but remember that the U was removed. The location also has A. Remember that the A was later removed. So when you go to the R, you should change the locate to loc, the oku to ok. Okay, it's just a way to remind you. You can also generate correlation with p-values. Look at this one. So you are going to generate a correlation matrix, but this time with p-values. That is with significant values telling you whether the relationship is not just negative or positive, but it is statistically significantly negative or statistically significantly positive. Okay. So how do you do that? Well, you will use this command to do that. You can see that I have rcore dot as matrix, rcore dot as matrix. So this is a command here, 217 command. I'm going to use that to generate it. And remember, to do that, you need to run a package called library h miscellaneous. Okay. I didn't do that. That is why the thing didn't work. So I'm going to go back to 216, run the command, and then after that, run this. Now it has worked. Okay. So watch it so carefully. I'm making it bigger so you see. So what this means is that the correlation between P and N is this value. Okay, let me just show. The correlation between P and M is this negative 0.51. That is a correlation between P and M. It is a second row, far right. And its P value should be the second row here, far right, which is, 4 zeros before the 7. Okay. this 7e minus the exponent to the power 0.7, it simply means 4 zeros before the 7. So 0.307. What does that mean? It means that the p-value is 0. And when the p-value is 0, it means that the correlation you have above here is significant. So there's a significant negative correlation between price and between what? Quantity and, or no, between price and income. Okay. The correlation is 51% and is negative and is significant. How do you know it's significant? The significance is picked from here because the value on the bottom refers to the p-value. So you should be able to use p-value to tell whether a correlation is significant or is not significant. You should be able to use the p-value. But that's it. The command is there. Once you run the command, you'll be able to get it. Now we are ready to do the simple regression. Simple regression. Let me see who has been following me so far to do something. Like I said, majority of you didn't fully prepare and copy the commands. But has somebody been following me? Raise your hand and let me see if you are following me. If you are at least doing something along with me so far, raise your hand and let me see. If you are doing something, we have 33 people. That's interesting. That's interesting. Okay. Now, if you were actually doing the command and you have a problem, okay, you would have told me long ago by now. I mean, if you were going along with me, okay, you would also have told me long ago by now. But go through it step by step. I have these videos recorded. I have previous ones recorded on the channel. Watch it and try your hands because all the commands are there. But you see, when you have your own, which is your own assignment, you have to create your commands yourself to find the answers. So try and do that. I will give you an assignment this week. You submit it in 10 days. Okay. So it's important that at least you are following something. And even if you're not following fully, you can watch it over and over again to be able to get it. Now, correlation is done. We want to do regression. One of the first things you can do is we can plot a simple regression. In this case, we want to look at the simple regression between Q, quantity demanded, and price, which is, we call the coefficient of price beta 1. So we want to run this model. Okay. This is a model we want to run. And we have the column for quantity, we have the column for price. So let's do that. The column for quantity, the column for price. Now this command is going to do that for you. Okay. This very command you see plot, okay, is going to do that. Sometimes you have to run the regression before you come and do the plot. Running the regression, this is it, the one below here. That will run the regression. Yes, Posh.
Thank you, sir. So do we have to copy it and then put it in the command?
Yeah.
Okay, thank you.
That's what I indicated the last time. But if you have done that, you see that you just be running along with me beautifully. Mara. You have a question? Okay, so let's
Hello, sir.
proceed.
Can you hear me?
Yes.
Yes, I was saying that there's PDF file, so we cannot copy. Is it possible we can get it in a different version?
You cannot copy
Thank
from
you.
the PDF. Is that what you said? No, you can copy from the PDF. Actually, that's what I'm also using. I'm just copying from the PDF. Yes, Mary.
Yes, sir. Good evening.
So we cannot copy from the PDF. Okay, thank you. Right.
Yeah, Mary, go ahead.
So when I entered the command for the gene simple, It gives me an error.
Yeah,
Same
well,
here.
if it gives you an error, it means that you have not run certain previous packages. So if there's any package above that you were supposed to run, you have to go and run it. Okay. I'm coming to run my Gen Simple, then you have a look at it.
Okay, sir. Thank you.
So this is a Gen Simple here that you guys have run. Now, there are two things. Before you can run the Gen Simple, you have to attach this command, attach Gen. If you don't do attach Gen, it might not work. Okay, because you have to attach. Other than that, you have to write Gen dollar before the kill. So I'm going to show you what I mean. Okay, mine. Oh no, I did a plot. The plot as well. Mine I've already attached, so obviously it will show. But you will have to attach, just attach. Later on, when you're about to close your R, you will detach by using the next command. So once you do the attach, it will print the memory of the variables onto the memory of R, each variable into R, so that you don't have to bring a dollar symbol in front of it with a data sign. So just do the attach first in this my command 228 here. Okay, do it. Just type it if it's not there in yours. It's supposed to be somewhere in yours. Type it and run it. And then after that, run your Gen Simple. It should work. Let me know if it works. Let me know if it works. Okay. So let me go to the Gen Simple. And then I run my Gen Simple. Look down there in the console. It's running. It's going to show the results, and there you go. The results are now showing down there. The results are shown down there in the console. Okay, you can see it here. Beautifully shown. So you should have do that touch before you run. And let me know if it works. Those of you, when you don't see that touch, you have to type it, give it a gap and type it yourself before you run. Did it work?
It works. Yes,
All right,
please.
okay. So let's move on. So I've done a drawing of the simple relationship between quantity demanded and price, and you can see it on the right here. Clearly, the red line shows the fitted line, and it shows clearly that there's a negative relationship between quantity and price. You can see that. Again, when you come to the regression results, look down there in the bottom, okay? The coefficient of price is negative 14.26, which shows a negative relationship between price and quantity demanded. This is just a preliminary to show you how it works. One of the assumptions of regression is that this fitted line can be generated. Okay? The fitted line is a predicted value. Remember, the actual value in this is in the Excel. The predicted value is what you create. We can use this command here, 234, to run the fitted value. So this fitted value is the value for each actual value. If you go and check, the actual value for observation 1, which is shop 1, was 160, but the fitted value is 162. So there's a difference. And it is this difference we call the residual. The next command will show that residual. Let me show you. So you can see that the residual is showing -2. Okay? So that -2 is the difference between the explained and the unexplained, or the difference between the actual versus the predicted value. When I say actual, I'm talking about actual quantity demanded and then the predicted quantity demanded. The difference between them is a residual, the error term that you might call. There is an assumption in regression that says that the expected value of the error term must be 0. This is it. This command shows that expected value of the error term must be 0. That simply means that the mean of all the errors should be 0. Let's run this command to see whether the mean of all the errors is 0. I just did that. Look down there. The value clearly shows that there are 16 zeros before the 4. So it means that the error on average is 0. You can do other things like the confidence interval, the ANOVA. You can run all of them here. This will show the confidence interval for the price. Then you can generate an ANOVA table as well. We're not interested in those. What we are interested in is a multiple regression. That's what we are interested in. And I'm going to generate the multiple regression, and then we can ask a series of questions from it. So this command 248 is a multiple regression. Remember, you've already done that touch. So just run. I call the multiple regression gene multi. And I just picked each independent variable, PCM, lock, awk, rel. The name of the data is gene, and then the summary of the results of gene multi. Run it and see the results at the console. That's it. That's a beautiful result you see down there in the console. Let me just make this one bigger so that you see the results better. This is it. This result will also give you the entire formula, as you can see. Under exam condition, I can choose to bring a result like this. And I'll ask you a series of questions based on this result. This is what I'm about to do now for this one. So I'm going to show you a series of questions based on this result. But I hope that those of you who are working along with me, you've been able to generate this multiple regression model. Let me see my hands if you've been able to do that, because that will mean that.
No, sir, I'm getting error.
Okay. Yes, Denise.
I've been able to run it, please.
Very good. There's always some people who will be able to do it. There will always be some. Okay. If you have an error, look through the error. The error at the bottom will tell you exactly what the problem is. Read it and make some sense out of it, and that will help you in the way you go around it. Well, what I'm going to do is I'm going to show you these results, and then we ask a series of questions based on the result. So the first question I'll be asking you, let me see something. The first question I'm going to be asking you is a very simple question. And like I said, there's going to be a series of questions that you'll be working when it comes to this result. But the first one I'm going to be working will come from the way you look at it. The first question is about the coefficient of determination. Write it down. Okay. Is a regression model reliable or well fit? That's a question. Is a regression model reliable or well fit? Is a regression model reliable or well fit? Is a regression model reliable or well fit? Now, how do you tell whether the regression model is reliable or well fit? One way you use to tell whether the regression model is reliable or well fit is by using something known as the coefficient of the determination. Okay. The coefficient of determination. The coefficient of determination. It's also called the R square. Take note. It's also called the R square. This is where you gotta have your pen and paper ready. The R square. What is that? The R square in R sometimes is called multiple R. In R, it is called multiple R. What is that? It tells you the variation in the dependent variable as a result of the variability in all the independent variables. It tells you the variability changes in the dependent variable as a result of the changes happening in the entire regression model. And the changes in the entire regression model is the same as the variability within the independent variables. Let me give you a scenario for you to appreciate this. The R square helps you to know the extent to which all the combination, the combined forces of the independent variables, how they come together to influence the dependent variable in percentage terms. So if the R square is bigger, it's good news. If it is smaller, it's not all that good news. To determine whether the regression model is fit, you have to check the value of the R square. And according to Hare et al., 2005, which is also what I'm using, if the R square is bigger than 50%, then the regression model is well fit. If the R square is bigger than 50%, or is 50% or more, then the regression model is well fit. So check your R square. Check whether it's 50% or more, and you will know whether the regression model is reliable, dependable, or well fit. Mary.
Yes, sir. Can you take that again, please?
Which one? If the R square is 50% or more, it means that the regression model is reliable or well fit. It means that the regression model is reliable or well fit. So look at the data. Okay. Look at the results that you see on your screen. You too will have a similar result like this. Do you see the value of the R square anywhere? Do you see the value of the R square anywhere? Anybody sees the value of the R square? Remember, I told you that in the R.
Yes, sir.
What is the name of the R square here?
Multiple R squared.
Multiple R squared.
Very good. And what is the value in percentage terms?
98.84.
98%.
Good. Always round it to 2 decimal places. So what would that be?
98.84.
Okay, so that is 99. Okay, always round it, 99. Okay. You convert what you see here on you convert it to 2 decimals. That will be 0.99. And then you now take a percentage. So based on this, would you say that the R square is reliable or is not reliable?
It's reliable.
It is reliable. Why?
It's more than 50%.
Good. That's it. That is how you're able to confirm that the regression model is well fit. Posh.
So I also see the adjusted R squared.
Yeah, I'm
And I
coming
was-
to that.
Okay, thank you.
Now you got to know how to interpret this very R square. Because you already know that the value is 99%. When you are interpreting it, you will say that 99% of the variation in the quantity demanded of gene betas, because we are talking about real life situation. 99% of the variability within the quantity demanded of gene betas is explained by all the independent variables. It's explained by all the independent variables. So you should, if the value is, say, 20%, you will say that 20% of the variation in the quantity demanded of gene betas is explained by all the independent variables. So learn to interpret the R square. There is also the adjusted R square. The adjusted R square simply penalizes the inclusion of irrelevant variables in the model. It punishes, it penalizes the inclusion of irrelevant variables in the model. So let's assume that the model has some variables, and you decide that within this particular example model, this quantity demanded of Jimbe test model, you think that the weather can play a role, or you believe that the type of economy, or you believe that whether you are white or black can influence the quantity demanded of the Jimbe test. And so you went to include race in the model. And yet race is not a relevant variable to be included. You'll be punished. Well, the thing is that you got to be punished for doing that. And which means the R square was supposed to come down, but the R square does not come down. Hence the adjusted R square. The adjusted R square will adjust for that mistake you made for including that irrelevant variable, and then it will reduce the R square, making it to be called the adjusted R square. So the adjusted R square is always smaller, or at the most equal to the R square. It is always smaller or equal to the R square. In other words, the R square will be bigger than the adjusted in most cases. In the case when they are equal, what does that mean? Who can tell me? In the case when they are equal, remember adjusted R square is written like this, with R bar square. In the case the R square equals the R bar square, what does that mean? Let me see if somebody can crack it without the explanation. Good. Someone is right. The adjusted R square being equal to the R square means that there is no irrelevant variable in the model. And therefore, the variables that have been included are more or less fine. In our case, if you look at adjusted R square, look at the value carefully, okay, you will see that adjusted R square is 99%. The R square is also 99%. Correct to 2 decimal places. So it means that this model is well fit and there appears to be no irrelevant variable. That's it. Now we go to the next thing. We check the next point, and that next point is about determining the significance of the variables. Here's a question. Using the p-value, which means you have to use a p-value, using just the p-value, which variables are significant, which variables coefficients are not significant? Which variables are significant? When we say a variable is significant, what we mean is that that variable is good in determining is good in predicting the dependent variable, the outcome variable, the response variable. So as you know, all the variables are trying, all the independent variables are trying to predict the dependent variable. Each one of them is trying and trying and trying to predict. Which one is better in terms of significance in predicting the dependent variable? Which one is better? Now, to do that, you need to check the p-value of each variable. So when you look on the variable section here, if you look at it carefully, you will see that for price like this, you can see that there is, on top of the red line that I've written there, are the information for price. Remember something here, something very important, is that the estimate here divided by the standard error will always give you the t statistic. If you don't know, write it down. The estimate divided by the standard error is equal to the t statistic. When you read the t statistic value from the table, which we used to do, you go and read the test statistic from the table, you can now get the p-value. The p-value. Ladies and gentlemen, the p-value is what you are seeing here as the last column. They call it probability. The p-value is what you have there as the last column, known as probability. Now, in order to determine whether a particular independent variable, say P or M or religion Muslim, in order to determine which one of them is significant, you have to check the p-value. And the rule is very simple. If the p-value is less than or equal to 0.05, then that independent variable is significant. If the p-value is less than or equal to 5%, then the independent variable is significant. Then the independent variable is very, very significant. Now, so I'm going to ask you to tell me which variable do you think is significant? Well, all you got to do is to check the p-value. There is a way to even check whether it is significant at what percent. Okay, I'll talk about that briefly if there's time. But the significant is you check the p-value. So let's go to the p-value for each value. Always don't bother yourself with the intercept. The intercept is not too necessary. So let's ignore that. Let's start with the price. Looking at the price and its p-value, look at the price and its p-value. Would you say price is significant or is not significant? Who can tell us? Just based strictly on the criteria we gave. Would you say price is significant or is insignificant? Who can tell us? Yes. Denise.
I think it's significant
Okay,
because
why do you
it's
say that?
approximately 0.05.
Good. That means you've converted it to 2 decimals, isn't it?
Yes, please.
Very good. I agree with you. If you had not converted it to 2 decimals, would it have been significant or it wouldn't?
No, it wouldn't have been because it would have been greater than 0.05.
Exactly. It would have been 5.3%. It wouldn't have been 5%. Very good. So on the basis of that, we can say that it is significant. All right. Now, what about income? Who can tell us? Look at the p-value for income. Okay. Tell us, is it significant or is not significant after converting it to 2 decimal places? After converting it to 2 decimal places, is it significant or it is not significant? You can check. Well, you can check. If you convert it to 2 decimal places, it's going to be 0.01. That is 1%, which is less than 5%, and therefore is significant. Income, if you look at it, is 20%, and therefore it is insignificant. Location urban, okay, it is 19%, and therefore it is insignificant. Occupation teaching is significant. Occupation trading is significant. Religion Muslim is significant. They are all 0, 0, 0, 0. Religion Christian is also significant. Now, the thing about R is that it goes beyond just telling you whether it's significant or insignificant, and also gives you significant at what percent. So the stars here gives you a clue. Okay. The stars will give you a clue. The stars will give you a clue. So normally when you are answering the questions, it helps you to follow more. So you can see that this is what we normally call partial significance. When it has 3 stars, it means that it's significant at 0.1%. Take note. When it has 3 stars, it is significant at 0.1%. When it is 2 stars, it is significant at 1%, not 0.1%. When it is a star, it is significant at 5%. Okay. And when it is a dot, it's significant at 10% when it is a dot. So you can see that in principle, in this very example, based on what the stars are showing, price will be significant at 10%, which means that it's not significant at 5%, but 10%. But we had to round it and to 2 decimal places. That is why we concluded that price is significant. See, when we say price is significant, what it means is that price is statistically capable of influencing the quantity demanded of generators. Okay. In other words, the negative relationship here is not a small situation. It is a huge situation, making it significant. All right. Now, the next question is to determine the joint significance. So what we just did is called partial significance. Partial significance. But let's look at the joint significance. And the question goes like this, for joint significance. It's a very simple question. Are the independent variables jointly significant? Are the independent variables jointly significant? If you want to tell whether the independent variables are jointly significant, what you do is you check something. When we say, are they jointly significant, what we mean is that individually, a particular independent variable might not be significant individually, separately. But when you combine them together, when you put all the powers combined, Captain Planet, when you combine them together jointly, they can have a significant effect on the dependent variable. And that's what the question is asking you. Could you tell whether they have a significant effect on the dependent variable? In order to answer that, always use the p-value for the F statistic. Always use the p-value for the F statistic. It's the last thing you will see in the result. The p-value for the F statistic. And this p-value in this example is here. Okay. This is a p-value. What does this mean? Who can tell us? What does this p-value mean, actually? The value is actually equal to what? If you look at it carefully. Carefully. Just as we saw with occupation trading up here. Just as we saw with occupation, religion Christian up here. Okay. When you look at this, down here for the F statistic, what does it mean? It means that the p-value is equal to what? In simple terms, yeah, it's equal to 0. That's what it means. The p-value equals 0. Okay, you want to look at it here. It means that there are 16 zeros before the 2. So the p-value is 0. So which means that the errors, the actual error made in this research is 0. And therefore, all the coefficients are truly jointly significant. All the coefficients are truly jointly significant. Normally, when you want to justify this, you have to justify it the way it is here. So in this very example, I've written it here for you. When you check it, it says that use only the F test, reject the null hypothesis if the p-value is less than alpha. Since the p-value is 0, which is less than 5%, all the coefficients are jointly significant. All the coefficients are jointly significant. Okay, so now being able to determine the joint significance of the variables. The next question we want to look at is this question. Specify the regression model for Burkutu Ventures. Ladies and gentlemen, this is one of the important questions you don't want to toy with. Specify the regression model. How do you specify the model? Well, last time we looked at specification of the model. That specification of the model is where you are bringing the betas. You are bringing the beta naught, beta 1, beta 2, beta 3, and all of that. But we're even looking at quantity demanded. We looked at wage. We even looked at blood pressure the last time. So if you are ever going to specify the model, let me give you an advice. If you are ever going to specify the model, there's something you got to do. What you want to do, and I'm giving you a clue, is to go and look at the correlation matrix. I'm talking about the Excel one. That's why last time I showed you how to do the Excel one. Look at the correlation matrix. Now, if you don't have the correlation matrix for the Excel one, what you want to do is you want to look at the regression model just as it is, without changing anything, just as it is. I'm going to use that one for you. So let's look at the regression model just as it is. This is a regression model just as it is. Now, based on the regression model, if you look here, it's even easier. If you look here in the regression model, watch this part here. This part here is what is going to help you to sense it. And by the way, it's the same thing on this far left here. Far left here, the same names. But we focus on this because the thing is that if I give you this in the exam, this very one, you will find it easy. You just look at it. But based on this alone, and looking at the preamble that you already have, you will note that the dependent variable is a quantity demand. In fact, in this example, you know. But under the exam condition, what you got to note is that the dependent variable is not part of the independent variables here. It's not part. The dependent variable is not part. I would have given you a result, but probably I will give you a result only like this. Maybe I'll give you the entire results like that. In that case, the dependent variable is the first one, so it's easy. It's easy. The dependent variable is the first one. But if you don't have the entire results, just know that to get a dependent variable, you have to go and read the storyline. Anyway, how do you specify the model? First thing you got to do is to write the dependent variable. Write your equal to. Bring the beta naught, because you are going to attach beta to them. Bring a plus. And then come and write the first independent variable, which is also the first one here. Remember, the intercept is the beta naught you wrote. So you now attach beta 1 and write price. Then bring the next one, beta 2, and then come and select the next variable, which is complement price. Then you write yourself beta 3, come and select the third variable, which is income, plus beta 4, come and select the next variable, which is log urban. And this is where you got to be careful. You write it exactly as it is. If it is log urban, write it in full, log urban, just as it is there. Then you write your beta 5. The next variable is awk teaching. So come and write this exactly as it is, awk teaching. Exactly, don't change anything. Then plus beta 6, come and look at the next variable, which is awk trading. And then you continue like that all the way, okay, until you get to the beta 8. So let's say you got into beta 8. Then you have your religion Muslims. After that, you have plus your error term, don't forget that, which is UI. Without the error term, you did nothing. Everything will be 0. No specification model without an error term, that is 0. Any best writing of the specification model without the error term is 0. So you don't forget to add the error term. This is how you specify the Brukutu Ventures regression model. So write all of it, and that will show. Whilst I'm writing, the best would be for you to be writing the same thing. Because as you are writing, there is an information symmetry between your fingers and your brain in catching the fire. So when you look at the slides here, the one I wrote here, the one that you guys can see I've written here, is with the Excel one. Okay, that is the one that I wrote there. But the one you would write, because the Excel one use acronyms a lot, but the R did not use acronyms a lot. But you've seen the R one. Okay, so that is how you will attack the R one. Please take a note. I just use the R one, so use that. Okay. The next question is to specify the entire regression model. Specify the entire regression model. Sorry, that's what we got. The next one is to write the estimated regression equation. Write the estimated regression equation. Write the estimated regression equation. How do you do that? Well, look at it. We did it last time. The estimated equation is different from the regression model. You guys remember the difference? We looked at that difference last time. Do you remember the difference between the estimated regression model as well as the specified regression model? We indicated that there are two main differences between them. Two main differences between the estimated and the specified. Who remembers? Who remembers? Me? Class rep, are you there?
Yes, Doc, please, I'm here.
Good. Tell me the answer. Or I should fly again.
Doc.
Okay. So the estimated regression, I mean, the fact that you can type here but you can't talk, that alone is quite interesting. Okay. All right. So the estimated regression equation has no error term. Okay. It has no error term like this. The specified model has an error term, but the estimated has no error term. Remember, I told you that even though these ones were using the Excel, the actual ones were using the variables. And you have to write it in such a way that you convert it to 2 decimal places. Okay, so take note of that. What I'm going to do now is I'm going to use a regression one in the R to write it for you. So they are on the left-hand side here. And then the coefficients are here. It is this coefficient you are going to use. They are the ones under the estimate. Everything under the estimate. That's what you're going to use. So we are actually going to use these estimates here to write the equation. How do you do that? It's very simple. All you do is that you write kill, which is the dependent variable first. So you write the dependent variable, you bring equal to, if it has been the specified model, it would have been the beta naught. But now the beta naught is the intercept. If you look at the coefficient here, it is 280.27. Write it, 280.27. Write it. You're not writing, you're watching me. Write it. Then the next one is to write the estimate, okay, which is the price. Remember, all I'm doing is I'm replacing the beta value with this estimate value. And it is actually 2 decimals is negative 3.15. Then you attach the letter P to it because the price was given a name of P. The next one, check it. The next one is a minus as well. That's why I'm not writing plus plus. The next one is a minus. And when you convert it to be 0.11, so that will be minus 0.11. And what is a letter? It is C. It is C. So that's what we just did. The next one is for income. And when you check the value, is minus 0.98. So you do minus 0.98 and then write income, which is M. The next one is lock urban, and that is minus 5.11. So you write minus 5.11, then you write lock urban, just as it is there, lock urban. The next one is minus 19.43. So you write minus 19.43. And what is the value there? OC teaching. OC teaching. OC teaching. Okay. You write it there. The next one is minus 46.47. So you write minus 46.47. Write it down. Write it down. You don't write it down. Okay. 46.47. And then that is OC teaching, OC trading. Okay, so you do OC trading. The next one is plus, if you check it, it's plus 15.55, and that is real Christians. Real Christians, just as it is. You don't change the words. Real Christians. I'm doing this to the end for you for a reason. Then the next one is negative 23, okay? Negative 23.01. And that is religion or real Muslims. Real Muslims. Now, this is an estimated equation, so you don't bring any error term. You leave the rest just like that. You leave the rest just like that. If you don't have, if it's not clear, let me know. If it's not clear, just let me know. It has to be pretty simple. If you were following and writing it along with me, it has to be fairly simple. Fairly simple. Any question on that? So specifying the model, this is 8 marks, I'm telling you. Specifying the model is very important because you are going to use that for prediction. Okay? And because you're going to use it for prediction, it's always important to specify the model in a very, very nice way. In a very, very nice way. Okay, next. Now that you specify the model, we can now go to the next level of information or question that you are likely to encounter. We'll come to the prediction, but before we finish, we get to the prediction, there's just one more thing I need to talk about, and that is multicollinearity. You remember that the last time we looked at multicollinearity, we selected some independent variables, okay? And after selecting those independent variables, we were able to identify why those very independent variables were multicollinear. Okay. And just remind yourself that multicollinearity exists when two independent variables are highly correlated that it becomes difficult to separate the partial effect of one from the other on the dependent variable. That's multicollinearity. Now, if you have an independent variable that is multicollinear with another independent variable, it means that the two of them, one is redundant because they are doing the same job in the same work. So one becomes more or less redundant, superfluous, unnecessary. Now, we need to find a way to handle that. And one way to handle that is to first measure the variance inflation factor. Multicollinearity can be a case, so sometimes you want to handle it. The variance inflation factor is given by 1 over 1 minus the R squared. That's what you see on your screen here. Now, the software can calculate the variance inflation factor for each independent variable. And based on that, it can tell you whether an independent variable is good or is not good. There's a rule, there's a general rule in practical work. If the VIF is more than 10, that shows high multicollinearity. So we are going to look at our variables, coefficient again. In fact, you guys can remember that you were the one that selected the independent variables that were multicollinear based on the coefficient. So which independent variables coefficients signify the multicollinearity? Which numbers did you choose the last time? You can remember them. Which number was the first one that we selected the last time?
I think it was 0.76.
That is good. The first one we selected was 0.76. What was the second one? That's if you wrote it.
-0.74.
All right. And the last one?
-0.73.
Correct. So those were the ones. If you check both of them, you can see that P is featuring. Okay, that's P. Okay, C is featuring. OTR is featuring. M is also featuring. RM is also featuring. We got to check these variables and to see which one of them has a higher variance inflation factor than the other one. And the rule is simple. Okay, for this purpose, for our purpose, the variable with a higher VIF must go. Okay, the variable with a higher VIF must go. When I say must go, in applied work, it may mean that you have to remove that variable from the system. So here's a question. Using only the VIF, which one of the pairs of variables selected to be multicollinear may be deleted? Now, let's go to the R and see how we generate the VIF, first of all. After you've calculated all the R, you can easily generate the VIF. Okay. So that's what we just want to do. We just want to generate the VIF, and then we can papa. So how do you generate the VIF? Well, one way is, first of all, if this is not available, you do that. It's called library car. By the way, everything is in your slides. Okay? It's called library car. If you check the R, it gives you the command. One is to run this command here. Okay, as you can see, run this command here. And it will help you to be able to know. Another is to check if the VIF is serious. Practical ones are what I'm showing you. By running this command, this is a command and the result is what is down here. Or check which particular independent variable is a problem child. So this one will tell you for each one that is a problem child and each one that is not a problem child. But normally, after I have given you the R result, I will give you the VIF for each independent variable. There is something practical you should know, that ideally, the VIF for a dummy variable is not necessary. Ideally. Go and find out why, because there's a question on that. Ideally, the VIF for a dummy variable is not necessary. Find out why. Why is that the case? Okay. So you can generate the VIF. Okay. Let me see whether I can generate a particular VIF for you. Okay. There's a command. I can run this model again and use a certain command. You have to first install a package called library tools, which I just did. Now, when I run this command, it will give me the p-value at the end of each variable. Okay? And if I want the VIF, it will also give me the VIF. So this is what I would generate for you. So you will see the VIF for each variable starting from here. This is the last column, by the way. It's the one you will see at the last column. So the variables that we selected to be multicollinear, these variables that we selected. Okay, remember the first one was it price and OTR? Is that it? I think so. So if you look at OTR, OTR is occupation teaching, occupation trading. If you check the occupation trading, remember I told you that ideally we don't normally deal with the dummy variable, but we are using it for this purpose. So if you check the occupation trading, the VIF for it, and you check for price, the VIF for it, which one do you think that it may be deleted? Which one do you think it may be deleted? Based on this result, who can tell us? Which one may be deleted? If you check carefully, yeah. Okay, if you check carefully, it is occupation trading because it has a higher VIF of 80 compared to that of the price. Okay, and that is the one that may be deleted. It doesn't mean, remember I told you earlier on that VIF with dummy variables is a very, very sleepy area. But for our purpose, we're just doing it. The next variable we saw was price and complement price, if I could remember. Based on the complement price, a price is already 24. Complement price is 10.38. So price may be deleted based on the VIF assassination and behavior. Okay. And then the final one was M and, is it RM and M? Okay. If you check M, it is 10.81. RM is 44.19. Okay. And therefore, on the basis of this, RM may be deleted. So you can use a VIF to check each independent variable that may be deleted in that regard. Now, we go to interpretation of the results. Interpretation of the results. Interpretation is very important. I will not lie to you. And please take your pen and paper and follow me whilst I do the interpretation. Now, in order to do the interpretation, I'm going to go back to the result, the original one. This is the results of the original model. And if you look at this results of the original model, every independent variable has a role it's playing, and its role is determined by the estimates that it brings to the table, the estimate that it brings to the table, the estimate that it brings to the table, the estimate that it brings to the table. And these estimates are called coefficients. Yours is to interpret each one of them. The way you interpret a numerical variable, like price here, is not the same as the way you interpret a categorical variable, like religion, Christian. So what I'm going to do is that I'm going to say it, you write it, okay, down so that you know the interpretation of the independent variable, each one of them. Let's start with price. And watch the way I interpret price, because once I'm interpreting price, I will not include price as given. Take note. So start writing. On average, given the complement price of gin. Okay, let me start again. On average, let's continue. Because the thing is that you normally most people used to say that on average, holding all other factors constant. But what I'm doing is I'm just mentioning the factors because I want you to know the factors you are dealing with. That's why I use the word given. So on average, given the complement price of gin, I didn't say given the price of gin. Given the complement price of gin, that's a C. The average income of the people, that's an M. The location of the shop, that is a lock urban. The location of the shop, the occupation and religion of the people. Watch the way I say it. The occupation and religion of the people. You write it all as a sentence. A 1 unit increase in the price of gin. A 1 unit increase in the price of gin. A 1 unit increase in the price of gin decreases the quantity demanded of gin by 3.15 units. Decreases the quantity demanded of gin bitters by 3.15 units. So guys, watch it. I said given, and when I was saying given, I didn't include price because price was the one I was going to interpret. So the one you are going to interpret, you should not hold it as given. Then I said, given the complement price of gin. So I had to know the names. I didn't say given C, given M. I've got to mention all of the names properly. Then when it got to location, I didn't say location urban. No. I said given blah, 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 blah. And then I included location of the shop. I didn't say location urban of the shop. No. Because location is a dummy. So you don't have to specify which particular location that you are talking about. Then when it got to occupation, I didn't say occupation teaching, occupation trading. No. I combined them and said occupation and even said religion of the people. Not religion, Christian, religion, Muslim. And because I was saying that a 1 unit increase in the price of gin will decrease. Why decrease? Why decrease? Because I increased the quantity, the price of gin. So why the word decrease? What is the reason for that? Decrease, yeah. Decrease? Decrease because of the negative sign, which is 3.5. The 3.15 is a negative symbol. Okay. So anytime you are interpreting a negative value and you have already said a 1 unit increase in something, that will lead to a decrease in the other because it's negative. Okay. So that is how you interpret a numerical variable. It's number. So that's why it's rising and falling. It's a number. It's a number. It's a number. It's a number. That's why it's rising and falling. But when it is a categorical variable, like religion Muslim, watch it. Or in fact, let me even do religion Christian here, because it has a positive value instead of a negative value. You will say that on average, given the price and complement price of gin, you see, at this stage, I'm mentioning the price because it's not the one I'm interpreting. So on average, given the price and complement price of gin, income of the people, location of the shop, and the occupation of the people. You see, I didn't talk anything about religion because I'm explaining one of them. Okay. Given the price and complement price of gin, location of the shop, income of the people, and occupation of the people, quantity demanded is predicted to be, watch the words, quantity demanded is predicted or expected. Quantity demanded is predicted or expected to be 15.55 units more if the people are Christians than Buddhists. More if the people are Christians than Buddhists. More because the value is positive. Okay? So quantity demanded of gin bitters is predicted to be 15.55 units more because of the positive. Otherwise, what happens less if the people are Christians than the reference category. Remember last time we said that anytime you mention a dummy variable, you are mentioning it in comparison with the one that is not in the data. So how did I know that the Christians and Buddhists, why am I comparing it to Buddhists but not the Muslims? Because Muslim is here, Buddhist is not here. And we said that the one that is not there is usually the one that is the reference category. And you can see that Buddhist is not here. And as long as Buddhist is not here, Buddhist becomes the reference category. Okay, so, and then you can add, and it is significant by looking at the stars here. You can add, and this is significant. Let me repeat that. On average, given the price and complement price of gin, the average income of the people, location of the shop, and the occupation of the people, quantity demanded is expected or predicted to be 15.55 units more if the people are Christians than Muslims. How you put the words together matters. So these are very powerful interpretation. You can look at the rest in your own spare moment and then try to learn how to do exquisite interpretation of the data. Now we're left to the last one for today, and that is prediction. Prediction. And what I'm going to do with the prediction is that I'm going to just look at the last part of the prediction. The last part of the prediction. Look at the rest, okay, which are also in the slides for you to learn. And that is because I'm combining two things here to explain everything about prediction. Now, just cast your mind back. I told you that one thing about regression is for two things. Okay? I know that if I ask you, some of you will start wondering. Regression is for two things. One is to establish relationship and causality. Okay? That's regression. You want to establish relationship or causal relationship. That's regression. You want to establish causal relationship. And another part of regression is to predict. You only want to use prediction. You want to do a regression to do some predictive analytics. Here's a time to use it for prediction. And that answers the question. Because once I know the specific religion of a person, and I know clearly the price, and I'm so positive about the income, and I know whether the person is living in an urban or rural area, or whether the person is a teacher, a fisher, okay, or the person is a trader. If I know all of these information, I can predict the quantity demand. I can predict the dependent variable. So here's a question. We are going to calculate a dependent variable predicted for two scenarios and check which one is better. So the question says, compare the predicted quantity demanded of gin bitters, compare it. So in other words, compare the kill that was made by some Muslim traders. Watch the words carefully. It was made by some Muslim traders in an urban area. Put that in mind. Compare that with another quantity demanded that was made by some Buddhist fishers in a rural town. Given that in both cases, the gin bitter costs 15 cedis. So all of them, they are not going to change that price of gin because it's the same cost. It has a complement price of 15. And it has the average real income of the people to be 20. Once you have compared them, tell us what is causing the difference. Which factors are driving the difference? If I want to look at a question here, you can clearly see that there are some things here that are the same. For example, if you look at the price of the gin, it's the same, so it's not causing any difference. The complement price is the same, it's not causing any difference. The income of the customers are the same, so it's not causing any difference. So what is causing the difference? You will know that. What is causing the difference? Class rep. Are you there? Those are the advantages.
Dog, I'm here.
So we have to do the quantity demanded. Now this will follow from the equation that we wrote. Now, I'm going to show you the equation, but remember that in reality, those were not the names that were used. If you can remember, the name that was used for LU here was location Lock Urban, if you can remember. It was known as Lock Urban. So if you are actually using your own, this is exactly what you use, not the one that you're using. Lock Urban. The next one is OC teaching. OC teaching. That was the name that we use, Hawk teaching. All right. So with that in mind, the equation has been rewritten here. We are going to do a prediction. In the first scenario, let's go back to the storyline. In the first scenario, we are told that these people are Muslim traders in an urban town. Don't forget that. Muslim traders in an urban town. But look at the price. The price of gem bitters is 15, complement is 15, income is 20. So let's go and substitute them. So we have the equation 280.27 minus 3.15 or 16 approximately. So instead of P here, we'll write what number?
15.
15. Okay. And then, so you put your 15 here. Okay. So you move P and then you put your 15 there. And then minus OC 011C. The C has to be replaced with what number?
15.
15 again. Then the income. The income of the people was described, M was described as having what value?
20.
So you have the 20. Now you were told that the people are in an urban town. Now because they are in an urban town, LU will be what value?
1.
Good. Now 1 means is there. 0 means it's not there. So take note. 1 means that thing was there. And in this very example, if you check the first one, the group, they were Muslim traders in an urban town. Don't forget, Muslim traders in an urban town. So this LE will be 1. Now, occupation, teaching, what will it be?
0.
0, because these people are not teachers, they are traders. Occupation, trading, what will it be?
1.
1. Be 1, because the people are traders. So always note that whichever one you're looking at, the one that is not what it's supposed to be, that one will be 1. Okay. Now, religion Christian, what will it be?
0.
0. And religion Muslim?
1.
1. So when you substitute all of these and try to calculate, you will notice clearly, because now what is left is just calculate. And you check it and you get a value of approximately 136.7. That is how you work the first scenario. Now, remember the second scenario. The second scenario, we were told that the people, are Buddhist fishers in a rural area. Buddhist fishers in a rural area. So if we were to even go back to this point, remember Buddhist fishers in a rural area, what do you think the price here will be? Who can tell us quickly? Because remember, those ones were the same. So the price you got?
15.
15.
It doesn't change. Okay. So the price will be 15 here. What about the complement price?
15.
That will also be 15. The income?
20.
20.
Now the location urban, what will it be?
Location urban.
0.
0.
People were rural people. So that will be 0. What about location teaching?
0.
0, because the people were what?
Trading.
They were traders.
They were not traders. Let me just go back for you to see. They were not traders.
Fishing.
These were the
They
people.
were fishermen or
In
fishers.
fishing. Yes,
Fishing.
the Buddhist fish.
Fishers.
Yes.
Fishers, so don't say fishermen.
Fishers.
Fishes.
Okay. So that value there, because they are fishers, occupation trading will be what?
0.
The religion Christian will be what?
0. They are Buddhist.
0.
Muslim will be what?
0.
0.
That's it. So you can see that the last 5, they are all 0, 0, 0, 0, 0. So on the basis of that, you just handle this one, and then this one. And then subtract them from the 280. I've done both. Okay. I've done both, and you should check it as well. So the first scenario, when you do it carefully, you will notice that you're going to get a value of somewhere like 136. The second scenario, you're going to get 211. Now you take the difference between the two. 211 minus 136. You're going to get 74 higher for the second scenario than the first scenario. What was driving the difference? We knew clearly that price, income, and complement price were the same for each case. The only difference is the religion, also the location, as well as the occupation. So those were the factors driving the difference across these guys. So, as more importantly as it is, we're coming to the end of the entire caboodle. Go and run this regression model by yourself, the one I've just done with you. Run it by yourself and go through it fully, because I will give you this week your assignment where you have to generate your own R code by looking at the one I've done here. Generating your own based on the nature of the data you will get, and then answer the questions as fast as you can do. This will be a group work.
Well noted, Doc.
Ladies and gentlemen, that brings us to the end of the entire caboodle.
Kaboom.